Hey, colleagues, welcome back to the office. It's Steve, and welcome to our podcast for today. This is podcast number 26, The Hows and Whys of Creating User-Defined Functions in Excel, Part 2. In this presentation, we are going to take a deeper dive into user-defined functions and really kind of exploring more around macro programming inside of Excel. Macro, if you're not familiar with it, is essentially like a small computer program that can run inside of Excel that can do stuff on behalf of the user. They're fantastic, for example, for automating anything from simple tasks like formatting of columns, spacing, importing of data, to more complicated tasks like distribution of financial materials to the board of directors, creation of a variety of financial statements, and much more. A small subsection of macro programming is user-defined functions, which we'll talk about in depth here in a minute. But in a nutshell, a user-defined function is a calculation that is defined by the program of the user, meaning I, Steve Yoss, or whoever you happen to be, can write my own function to do whatever I would want it to do. You know, we're all familiar with, for example, sum or count, more complicated formulas like index and match, or whatever else that we choose to use. Well, we can write our own. We use a language called Visual Basic for applications, and we can make that calculation, or we can make that formula do whatever we would like it to be. So today, we're going to pull that lens back just a little bit further and talk into greater detail with respect to how user-defined functions work and how they operate. And we're going to look even further into the programming side of this, because ultimately with user-defined functions, it's a program. It's got to run based on what the user writes and what the user tells it to do. So I'm going to recap some of the highlights from our first presentation for this and in the first podcast, talking and just refreshing us on why this is a really kind of cool thing and what are some of the major advantages as well as issues that we should consider, as well as defining what that role of that user-defined function should be. Okay, and then we are going to spend a bulk of our presentation identifying the key functionality and terminology that is used to create user-defined functions. Okay, and in this section, we're going to talk through things like what is a function, what is a module, what is a subroutine, what is a class, and other things like that, which are essential terms you need to know if you're going to be writing your own macros, whether you're writing user-defined functions or more broadly macros inside of Excel, for you to be able to learn and master. And then we're going to take a look at a couple of more advanced user-defined functions. In our first user-defined function in the podcast that we did earlier in this series, we looked at creating basically just a very simple switch statement, which is like a kind of like a lookup in a way with respect to writing a user-defined function. In this example, we're going to look at a little bit more complicated of an example. I'm going to show you a few more things that you could do, especially when you have multiple of something. You know, if you're returning back a specific value, a single instance, that's a little bit simpler than when you're returning back maybe off of a range of cells. And understanding how we write stuff for one instance versus multiple instances would be really useful. So we'll take a look at some different formulas that we can do to incorporate user-defined functions to create our custom calculations inside of Excel. All right, before we get going here, I do want to remind you that if you are listening or watching to today's podcast, this is eligible for CPE credit. How cool is that? So with respect to our credit for today, all you have to do is head on over to cpetoday.com and use course code UDF2. When you use course code UDF2, you will be prompted to take a quick quiz on what you learned here today. Short 5 questions. It'll take you a couple of minutes and you will be breezed right through it. And you'll even get a certificate for today's class, which you could print out and then use to maintain your professional licensing. We all need some credits, and that always seems to sneak up on us so quickly. So listening to podcasts and watching us on YouTube is a great way that you could stay on top of and get maybe even in front of your professional licensing. So please consider it. In addition to earning your credits, you also get copies of the source materials for today, including the presentation and supplemental learning materials, as well as the sample files that I will be using for our presentation. So check it on out, cpetoday.com. Use course code UDF2. All righty. So let's go ahead and dive right into our presentation for today, and let's go ahead and start taking a look at what user-defined functions are, some of the benefits as well as risks associated with it. And then we're going to dive into our terminology and vocabulary and starting to familiarize ourselves with some of the more advanced techniques with respect to writing these user-defined functions. So again, in a nutshell, UDFs allow you to create your own custom calculations and your own custom functions that you can use to perform specific tasks. One of the examples that we're going to be looking at today is a very simple UDF that could be used to calculate, for example, income tax for an individual. You put in a taxable income amount and it pops out what that tax owed might be. What's nice about this is that you could create that user-defined function and then share it with your team. And then we know no matter what, when somebody puts in a particular taxable income, they're going to get a consistent answer across the whole team. You don't get one answer from Steve, another answer from Alex, so on and so forth. UDFs bring this wonderful sense of standardization across our team. Now, UDF go above and beyond our traditional Excel functions, and we can create UDFs for virtually any specific need we might have. So if there's some sort of weird calculation that we want to do or something that we want to be able to support inside of Excel that is not natively supported by the application, it could be extended with its own custom code, creating this calculation method for whatever we might need it to be. So some big advantages with respect to working with UDFs. First and foremost, again, automation. Automating complex functions are fantastic. We don't need to write really complex formulas from scratch. Imagine, like a big logical formula with many levels of nested if. You can have up to 64 levels of nested if. Well, imagine having to do that across the whole workbook. That would be really cumbersome. And what happens if you need to go and update that workbook? Well, that could be a big issue. With UDFs, we define the UDF as its own function, and we standardize and put the code into one section so that if we need to update it in the future, it's not hard. Essentially, it's all in one place. That formula calculation's in one place. And if we needed to update it to add another level or change how it calculates, we could do it in that UDF, and it will apply to wherever that UDF is being used. It gives us that consistency, as I mentioned a minute ago. Imagine you're doing this with you're creating a tax calculation. You don't run into an instance where Steve calculates it one way and Alex calculates it another way and Christian calculates it a third way. Well, we write the UDF, we share it with the team. Everybody is going to get the same answer regardless of how that calculation occurs. UDFs facilitate functionality that would be otherwise beyond the reach of many people. So, with UDFs, I can write it. I'm typically the guy in our company that does a lot of the Excel work. So I will put it together and then I could share it with my colleagues who maybe don't have the sophistication that I have with Excel. And you know what? They get the same great powerful features and calculation methods that I get. And I know it's going to work well for them. So UDFs offer a lot of benefits. However, there are some specific things that we should be aware of with respect to our user-defined functions that can cause issues for some users and in some particular use cases. Now, to create UDFs, you got to know VBA or Visual Basic for Applications. Now, we're going to spend more time probably than I've done in other podcasts talking about really technical things here because UDFs by their very design are a program. They're a very simple program, and the rules of this language and the syntax of this language and the grammar of this language are pretty easy to configure and pretty easy to determine, but it is a program nonetheless. And as such, it does require some programmer knowledge. However, I think that's a wonderful thing. I'm a big proponent of accountants learning to do some programming. I could tell you as a CPA myself, and also working in software development, this is such a wonderful marriage of skill and ability to be able to think analytically with respect to numbers and math and accounting, but then also be able to think analytically and critically about computer programs, and being able to smash those two things together has been enormously helpful and useful in my life. So VBA is a wonderful application of this knowledge. Additionally, I'll tell you, it's a great introduction. You learn a little bit of VBA, it's going to whet your beak, and you're going to say, what is out there in the world? What else can I go and learn? You know what? And that's probably going to lead you to SQL, structured query language. And then that might lead you to .NET. Then it might lead you to Python. It might lead you to all these other things. And you know what? you're going to look back and you're going to say thank you, because man, is my life and my career benefited by having just this knowledge available. UDFs do pose some security stuff. UDFs are a macro at the end of the game, at the end of the day. And even though they're very limited with respect to what they do, they can trigger, and they will trigger, these security issues inside of Excel telling you, hey, Steve, this is a macro. Don't open it. Well, as long as you wrote it or it came from a team member, it comes from a trusted location like SharePoint or a specific folder on your computer, it's probably okay. But do approach it with a little bit of caution. Think critically. But if you're interested on the security side of this, in episode 1, I did go into the macro security side of this pretty detailed and walk through the trust center, which can be very helpful for you to know. And we're not going to cover that today, other than just to remind you that macros do pose a security risk. UDFs are limited compared to traditional macros. One cell, one value. UDFs can, for example, can't spill into other cells, like, for example, a dynamic array formula can. When I put a calculation in, let's say an A1, the value has to be returned to where that UDF is located. So if it's an A1, it goes back to A1. Now I can copy it down to A2. I can copy it to B1. Additionally, I could point it at an array of cells, as you'll see when I count and sum by color. But one cell, one value. It can only come back into one place. Also, saving and retrieving UDFs can be a little bit awkward. We'll talk about this again. I talked about it briefly in episode 1, but I want to go into a little bit more detail because I feel like it warrants better discussion on how to save and recall your user-defined functions. Alrighty, so let's go ahead and have our first review question, and then we're going to go and take a look at our terminology and vocabulary. Alrighty. So, which of the following is an advantage of adding UDFs to Excel? So, what is an advantage of adding UDFs to Excel? Okay, is it UDFs facilitate custom forms and calculations, formulas and calculation? Absolutely, it does. Is it UDFs facilitate consistency across teams, work groups, and entire organization? You betcha it does. UDFs add functionality that might be beyond the reach of some Excel users. Absolutely. The correct answer here is all of the above. That is why we like UDFs. They allow us to do custom stuff that would otherwise not be possible. We can share that with our entire team and company, bringing consistency, and it's usually outside of the reach of most users. Alrighty, very cool. Let's go ahead and dive back into our presentation and talk through some of the terminology with respect to how and where Excel formulas might function. Okay, so there are 9 main phrases that I think are of value to you that you should know with respect to user defined functions. And these are not just, solely located in UDFs. These really kind of apply to anything around macro programming for Excel. And they are objects, parameters, procedures, properties, subroutines, collections, modules, and functions. Man, that was a lot. And what these actually are is that they are the basics of Visual Basic, the programming language that essentially runs a lot of Microsoft Office suite. It is a product of the Microsoft Corporation, and these are the basis of how we do programming inside of Excel. Now, VBA in general is what we consider a very high-level programming language, meaning it's very abstracted out. It's not, for example, interfacing with the actual hardware directly of the computer. So it's not like C++, for example. C++ is a very, very low language, or C, or Lisp, or some of these other languages that have been around forever. VBA runs really only inside of the Microsoft Office suite, and there are several layers of program between that and the underlying hardware that your machine is running on. And though it's different than BASIC, it's not BASIC in and of itself. BASIC, BASIC is an actual programming language. Visual Basic is really kind of designed to be easy, fast, quick to learn. It gives you a robust set of tools to write macros. And really, we only use VBA inside of the Office application. Could you use it elsewhere? I suppose you could, but anybody who has any sort of familiarity with respect to programming would tell you that, it's something to use inside of Office, and then as quickly as possible move on to something more powerful. Now, if you do some research beyond this session, you'll find a lot of different variations of Visual Basic. It is different in Office compared to other applications, and it's also different depending on the years. They have a standalone variation of VBA, then they have the VBA that's built into Microsoft Office. Okay, so they're going to be different with respect to what you do, and they've engineered different aspects of Visual Basic to focus on specific needs. And VBA for Excel is really kind of geared towards Excel, likewise for PowerPoint, Word, and other things. And we're going to solely focus kind of really on the Excel version of this, but just realize that VBA macro programming can be used inside of Word, PowerPoint, and really kind of any of the other Office applications as well. Okay, so now, why do we need to actually talk about these 9 things? Well, the answer is to really have a good position and a really good understanding of how these different terms work and relate with each other, and how to really be effective with respect to writing a macro in a user-defined function. Some working knowledge is really required, and the more you master these terms and the more you master how they work together and how they're interoperable with each other, the faster you're going to come up to speed and the better program you're going to write. Now, the basis of VBA, and really a lot of programming, is what we call object-oriented programming. And this is a really important thing. Most, if not all, programming languages that we are using today are object-oriented programming. It's a very efficient, very fast, and very transferable knowledge set, so that when you learn it, you're going to learn it pretty quickly, and then you can easily transfer that, for example, from VBA to something like Python, for that matter, or from VBA to something like C# or .NET or another language like that as well. Now, the characteristic means that when you're writing code, you select an object to act on before specifying the action on that specific object. So what we want to do when we're writing our Visual Basic is that we want to say, I want to work with this object, and with this object, I want to do this thing. So it's a very declarative language. It's something that we understand what we're going to do. We select what we want to do, and then there are a variety of verbs that go along with it that tell it to do what you've set it to do, but on that specific object that you've selected. Now, this methodology is very analogous to using simple nouns and verbs to construct first-grade sentences. And in some cases, it might be appropriate to place the verb before the noun, as in, for example, like run Jane. In this instance, we're saying, hey, the action I want is run. The object I want to do it with is on Jane. Now, in other cases, it might make more sense to put the noun before the verb, as in Jane run. When writing VBA code, the object noun is always before the verb or before the method. And so typically we will use some sort of separator or a delimiter between this. And in this particular instance, we use a period for VBA, although it does vary based off of programming language that you're using. So let's say, for example, I wanted to go and I wanted to get a particular item from my workbook. Well, what I would do is that I would first pick where I would want that data to come from, and then I would pick what I would want to do with it. So as an example of this, we would say range A2. In this instance, the noun would be A2, meaning cell A2, and it's probably the current worksheet. And then the dot basically delineates between the noun and the verb. And then with that, we're going to say select. And so in a nutshell, if we were to kind of write this in more of an English focus, it would say select cell A2. But this, in object-oriented programming, is how we would select it. So select cell A2. Now, in VBA, we also have collections, okay? When specifying the object, if an issue arises where there are multiple choices from which a specific object can be collected, that is, how do we pick one of many objects? I mean, if you think about it, for example, A2, if I've got 10 worksheets, there's 10 A2s. How do we tell it what we want? How do we tell it where we want to get the specific data? Well, that is a collection. Now, when referring to a collection of objects in worksheets for this example, we have to specify which one we want. It's always better to be as specific as we can with Excel rather than just kind of being broad. The broader we make it, the more ambiguity that gets injected in our code, and the higher chance that we're going to, for example, get a false positive for what we want. So in the code shown below, sheet 2 is established after the object but before the methods. And so in this particular instance, we're telling it, hey, look at the worksheets, specifically sheet 2, and then select sheet 2. And that allows us to be able to narrow it down from many into one. We have parameters. Now, for some methods that we are working with, we're going to have some options and additional functionality with it, So we might, for example, want to use a specific parameter to give it additional actions to take place in this for whatever we're trying to accomplish here. And parameters give that additional information to that specific action, and they're kind of like arguments with an Excel function. For example, let's look at a sum if. You'll typically have a range that you want to evaluate, a criteria, and then a sum range. So there will be 3 parameters. First is where to evaluate where that particular criteria should be evaluated against. So if we were, for example, looking at department, we would tell it to look at the department column. The second would be the criteria we want to evaluate. And it could either be a specific value, like for example, operations or marketing or accounting department, or we could point it at a cell like A1 or A2. And third would be where we would want to sum that particular value, where the math would take place. Well, those 3 things are parameters, and VBA works exactly the same. Parameters give us this additional information about the object action that we're trying to accomplish. For example, we have the print out method, which contains 8 parameters, all of which are optional as indicated in the sample materials that are provided in today's course. And so there's a whole bunch of additional parameters that we can use here. For example, for the print out method, we have the from, to, copies, preview, active printer, print to file, collate, print to file name. And these are all optional parameters, but what they allow us to do for the print out function, we could get really specific. I could print it to a specific printer. I could print page 1, page 2, page 3. But it gives us the ability when we're programming this to be very specific about what we would want to do. Now, if we just don't do anything, then it just prints generically, and it'll probably bring up the print dialog box, and then we can specify what we would like it to be. We have properties. Now, we can establish properties for these particular objects. Now, as implied by the name, properties are characteristics applied to that specific object. For example, let's say we wanted to change the height on something. Well, the default height in Excel, I'm going to say it's like 18 pixels or something like that, right? And you know what? I want it to be a little bit bigger than that. So what I could do is I could say, hey, for whatever I've done, make it bigger. Now, the way that would work would be that we declare what we would like the row height to be. So to change that active row height, we would use the following code. We say with the selection, make row height equal to 40. So row height is the noun in this particular instance, and we're setting that noun parameter to 40. So of the selection, make that row height 40. So those are on the small side with respect to as we're starting to work with our user-defined functions, we're going to start requiring and we're going to also start setting specific items to meet specific characteristics. Now, you could just write a simple UDF, that does a one thing. However, often what we need to do is we need UDFs to kind of work with other things. And often they're going to be working together in combination with other items. As you'll see here in a minute, as we start to look at, for example, the sum and counting by color, it's not just one user-defined function. There's often several. In programming, we have this concept called the single responsibility principle, meaning that for a specific class, I don't want it to be responsible for more than one thing at a time, meaning I don't want to write some massive function that's monolithic, hard to understand, hard to debug, that is doing 20 things at once. Ideally, what I want to do is just have a bunch of smaller functions and then use them independently with each other. It makes it easier to debug, makes it easier to maintain, and easier to change and easier to understand. So as we start to look at multiple things that we want to do, we need to start combining things into modules, procedures, subroutines, and other things like that. And that's where I personally think a lot of the power of UDFs come from. And what separates just somebody kind of passively listening, passively creating maybe one little, user-defined function, and somebody who's really harnessing the power of this is the ability to be able to get multiple things to work together and to combine them in such a way that accomplishes a specific goal. Now, one of the big macro things of this, and this is a foundational piece not only of VBA, but of a lot of programming, are modules. A module is a set of declarations followed by procedures. Okay, and so more simply stated with this, a module is a container used to store variables and all the code for a procedure. When we're recording macros, for example, Excel creates a new module for each macro. And everything that's required to accomplish that specific goal would be in that module. And so we can create modules through the macro recorder. We can create modules manually as well. And typically for a specific outcome or operation, the module will be all the code necessary to make that particular item sing and make that particular item function well. So as you're starting to look to accomplish specific things, whether it be doing a tax calculation or summing by, department or whatever you're choosing to do, you should be thinking both at the individual function level, but then how and what functions should be used to create your modules. And that module is the big picture of that specific item that you're looking to accomplish, that specific value you're looking to achieve. Now, inside of our modules, we've got procedure. A procedure is a block of code executed as a unit that performs specific actions. You could subdivide procedures into subroutines and functions. Okay, so if we start to think bigger picture here, okay, we've got our modules up here, and a module is a bunch of code. That bunch of code is either a subroutine or a function. Sorry, that subroutine is a bunch of procedures. Those procedures are a bunch of subroutines and functions. Now, when we are naming our procedures, we should keep in mind that we can use almost any name that we want, but there are some limitations, very similar to what we would see with defined names inside of Excel for tables or a range or something like that. Now, in the book provided, I kind of talk through this, and I give you some specific recommendations on what you can and cannot name your modules. The roots, the parameters for this and the security for this are quite simple though. Punctuation, procedure names can contain letters, numbers, and special characters. However, the first name has to be alphabetic. Do not use spaces, and it has to be less than 255 characters in length. So you can write a lot. I mean, 255 is a lot. I mean, that's more than Twitter. I think Twitter's 140 characters, so you can write a short haiku if need be. But generally, I try to keep these things pretty simple. I try to keep them, for example, count colors or sum by income or something of that nature. So avoid things like B17 when you're naming your procedures as well. Now, we have subroutines and we have functions. Okay, so modules. From modules, we have our procedures. Procedures, we have subroutines and functions. A subroutine is a procedure that executes a series of VBA commands. Okay, with subroutines, we can call other subroutines, which can call up other subroutines, and this is where recursion starts becoming really important, where we can have something call itself if particularly need be. And we can also call other functions to do kind of more complex stuff. Now, we want to create macros, especially macros that are going to be more complex, out of smaller, simpler building blocks, because those smaller, simpler building blocks of routines and functions allow them to be reused, and they allow them to be multi-purposed. We can also create what are called public subroutines and private subroutines. Okay, and with our building blocks here, what we talk about being public or private is that whether or not other procedures can call those subroutines, or you have to call the parent procedure to get to that private procedure. A public subroutine is one that other procedures can access and use for whatever purposes that they would like. For example, you might have a subroutine to do formatting, for example, for bolding or underlying, or it might be, for example, setting specific column width or height. Well, you might have a particular legitimate use case to allow other procedures to use your formatting subroutine. And that's totally cool. You know what? Because you might be working with a lot of different types of data. It might be, for example, anything from, sales data to expense data to formatting a balance sheet. And you might need that particular routine to bold your headers or to underline your totals. That's totally cool. However, you might have other private routines that would not make sense. Essentially, they're purpose-built, unique code that should be used in conjunction with other procedures and in the conjunction of a larger subroutine to prevent wonkiness and weird things for occurring. So it's really kind of up to you. There's no hard and fast rule. There's nothing Excel or Microsoft is going to do to force you to make something public or private. It's really kind of up to you on whether or not you're going to need that module for other things that you're doing. Subroutine procedures always begin with the word sub and end with end sub. Okay, so it's a very declarative thing. Here's my subroutine, starts here, ends here. Now we have functions, okay? Functions are procedures that return values when the procedure calls them. So when I'm working with a macro or user-defined function, my subroutine will call other functions that will then do things on our behalf. Now, if you looked at, for example, our first episode of this podcast, we talk about case statements. And the example that I provide there is a UDF where you give a day of the week and it will return back the day name, so there's actually not an Excel function that will return back a day name. It will, for example, tell you the date of something, but it won't tell you is it a Monday, a Tuesday, Wednesday, Thursday, or Friday, so on and so forth. Rather, it'll just give you the day of the week. Now, you could use custom formatting and to change the nature of how that is calculated, but if you wanted to do it programmatically with a formula, you can't do it. Well, we created a user-defined function that uses a case statement that evaluates it, where it will return back 1 to a 7, 1 being a Sunday, 2 being a Monday, so on and so forth. And we used a function to switch 1 to a Sunday, 2 to a Monday, so on and so forth. That function is a set of programs. It's a procedure that will ultimately return a value to the procedure that calls them. And when we're working with macros, subroutines call functions that will then return values to that subroutine. Now, like subroutine, functions can both be public and private, so we can use them independent of the thing that we're creating, or we can make them private where the private function only can use the subroutine that it is being written in. So it can only be used within that module. So public functions are available to all modules within a workbook versus private functions which are only available in the module that they are written with. Now, function procedures always begin with a function statement and then end with a function statement, end function as well, very similar to what we saw in the last slide with our subroutines. So that's a little bit about some of the main vernacular with respect to how the building blocks of user-defined functions come together. A user-defined function, user-defined function is essentially a collection of all of these things. It's an object-oriented program that takes parameters. Those parameters will often use procedures and methods and will have properties associated with them. They will often, for example, be using a variety of subroutines and other functions to create those calculations. And sometimes you'll use some of these, sometimes you'll use all of these. It just depends on the complexity of whatever you're trying to accomplish. So we're going to take a look at the VBA project window here in a minute, and then we're going to go ahead and dive into a couple of examples of other UDFs, as well as how to save some of these UDFs a little bit more effectively as well. So before we do that, let's go ahead and have our next review question. Okay, which of the following statements is true regarding modules? Modules can contain a single UDF. Modules can contain only a single macro. You could store multiple UDFs and or macros in a module, or none of the above. Well, the correct answer here is going to be you could store multiple UDFs and modules in a macro, in a module. So a module can contain a lot of different code and a lot of different macros, and they can really kind of contain whatever you might need. Okay, so let's go ahead and take a look real quick about the VBA layout. Now, the VBA project window is a separate window that will get added in addition to the window provided by Excel. So Excel, for example, has a dashboard, the ribbon, all the normal stuff that you've come to function. Visual Basic, when you load it up, always looks like it's straight out of 1998 because in a lot of ways it is. This is like functionality for Excel that just won't seem to die. So it looks old because it is old, and there is not a lot of maintenance and other things that are done to this to kind of keep this updated and maintained. It functions perfectly fine. They're just not putting a lot of money in aesthetics, if you will. Now, there are three main parts of this that you should be familiar with, okay? We've got our Project Explorer, we've got our Property window, and then we also have our Code window, okay? Where we write our code and where we work with our functions and macros are going to be over here into this code. The way we navigate our Excel workbook and navigate the macros inside of it is going to be in the Project Explorer. And then the Properties window is going to be what contains all the specific properties related to our work. Okay, now inside of our Explorer as well as in our properties, Project Explorer and properties, this is going to be where we're going to see all the specifics related to our project. So in the projects window, you're often going to see a lot of tabs and drop-down menus because, you might have macros running at different levels of this. You could have add-ins running, for example, like the solver add-in or any of the other Excel add-ins that we've created would be listed here. You're going to see all those different VBA projects listed. Additionally, you also see the properties, and things can have a lot of properties depending on what you're working with. So as an example here, you can see there's a lot of specific properties related to this specific workbook that you might interact with, and all of it is going to be listed right here. So let's go ahead and switch gears and take a look at a income tax calculation user-defined function. And so if you happen to have purchased today's course, you can follow along and try this out for yourself. And I'll just, again, show you a few things, and then we're going to switch over and take a look at our couple other ones as well. Okay. So what we have listed here is the sample file for today's class, which is the hows and whys of user-defined functions in Excel. Now, to get access to our Macro VBA tool, a couple different ways that we can do it. We, for example, can utilize the developer toolbar. We can go ahead and right-click up top here, and we can go ahead and select. Let me do that one more time. Okay, we can go ahead and select customize the ribbon, and then we can enable, for example, our developer toolbar right here. Okay, and in doing so, we will get our Visual Basic button listed. Okay, and we can also just come down here to the worksheets, right-click on the worksheets and select View Code, and that's my personal favorite way of accessing the Visual Basic tools. Let me just go ahead and close these. There we go. And this is the default VBA editor. And if we want to get really specific about it, this is what we would call a IDE, or Integrated Development Environment. So here is where we're actually going to do the work of creating our macros and creating our user-defined functions. So you'll see over here, I've got two workbooks open at the moment. We've got functions by color, which we'll take a look at it here in a moment. And then we have the hows and whys of user-defined functions. You'll see these separate. Each individual worksheets are listed. And then notice down here, you see modules. What are modules? A collection of code. And if we click module 1, for example, you will see that this is where all the code related to this specific UDFs live and where they function. Now, we have several user-defined functions inside of here. For example, our MFJ 2021 taxable income. And if we keep scrolling down here, there's I'm going to say 6 or 7 different UDFs that are listed, including counting words and fiscal year as well. Now, in the first episode of this podcast, I went through and I talked essentially how these function, but just as a reminder, okay, we create our modules. The modules are a collection of functions and subroutines. And when we write our function, we start it with the declaration of function, and we end it with a declaration of end function. And then the function is everything in between here. And so this function is using the scenario of calculating tax for a couple that is married filing joint for the 2021 tax year. So this function, for example, takes a single parameter, in this case, taxable income. So I'm going to pass in a number to it, and it will output a single value, in this case, what the taxable or tax owed for that particular couple might be. And it's a very simple function, very similar to what we were doing in the first example, where we were calculating the day name of the week. In this particular one, we're calculating that taxable income. So that value gets passed into that taxable income and declared as a variable, and then it evaluates the formula. So when it's above or below, and whenever it meets specific criteria, that's the value that gets calculated, and then ultimately the value that gets passed back. The way these functions work, and really this is true of any logical statement, they run until they get the first true parameter. So as we pass in a value, it tests to see it. So imagine that taxable income was $5,000. Well, is that value greater than 622.50? No, go to the next condition. Is it greater than 414,700? No, go to the next condition. So on and so forth. Well, ultimately it would end up coming down here. Is it greater than 0? Yes. Okay, then take 10%. And that's how that particular function would work. But this module is a collection of all of these. And as we start to, for example, evaluate and create our user-defined functions, then ultimately we can call them inside of Excel. So in this particular instance, here is our MFJ 2021. It is looking at the value presented in cell C4, and from that value in C4, it will then ultimately calculate the federal tax required. So let's come on up here. Let's just say it was $56,000 of taxable income. Okay, let's just say they had, $10,000 in deductions and exemptions. Well, ultimately the taxable income is $55,000. And that would be the federal income tax owed. You're more than welcome to check it out. It's a pretty simple macro overall, and we've got some other ones listed here, including for other tax statuses, including single, head of household, married filing separate, so on and so forth. There's also, for example, these other two down here, counting words and fiscal year. Okay. Believe it or not, there's not actually a formula that will count the number of words in a specific Excel cell. You can do that pretty easily inside of Word, but you can't do that inside of Excel. Well, here we've got our user-defined function, count words. Okay, and then down here, for example, we can also do this through multiple cells as well. So if we wanted to count through cells B7 through B9, let's go ahead and take a look at that UDF. Okay, so if we go over here, we look and come down to the bottom part here of Module 1, you'll see our count words. Okay, so now the only thing I wanted to point out with respect to this, let me just go ahead and see if I can zoom in on this for you. There we go. Okay, now the only thing I wanted to point out for this in here is what's called a loop. Okay. And then also notice that we've got a couple of additional declarative formulas as well as variables that are being declared in here. So there's a little bit more complexity with this. But what's interesting about this is the first example that I'm showing you of a loop. A loop is something that what happens if we've got multiple of them, And in this particular instance, we have multiple words. So this is where we would want to, in order to get the number of words, we need to loop through that cell, looking at each word in it, and then ultimately adding it to the current value. So for example, if that cell had a word in it, like Steve, well, it would return back 1. If it had Steve Yoss, it would return back 2, so on and so forth. So the loop essentially will go through each of these words, counting them, and then ultimately returning back that other value. Additionally, we can also point it at a range. So a range would be like cells B7 to B9. Well, we can also loop through it. So count all the cells in one, count all the words in one cell, and then go to the next cell until it is complete. Now, this is a little bit more complicated than what we're going to have time to discuss today, but I wanted you to know about this idea of loops, where we can point it at a range of things and then have it iterate through the data, ultimately calculating whatever is required. So it's not just so specific where it's just one cell, one value, but we can point it at a bunch of cells and have it calculate that value in a couple of different places. Okay, so that is a little bit with respect to how a loop might function. Overall, it is really powerful. And as you start to look at, for example, more important and more powerful Excel macros, looping will ultimately become one of the most important things that you're going to need to utilize. Okay, so let's talk about, and I'm just going to introduce this sample workbook for you. This is going to be for the folks that have already gotten their wet beak with respect to some of the macro programming. They want to do something a little bit more powerful. And this is sum and count by color. Okay, now this is a more complicated user-defined function. And what this does is that it will count or sum a specific destination by the color of the cell. This came up because I had a attendee many years ago that said, hey, Steve, the way we manage our data is through color stuff and color coordinating. And do you know if there's a way that I can basically color a cell and have it conditionally add or count based off of the color of a target color? Let's go ahead and take a look at this. Okay, so here's an example of this particular data. This is for ABC school, and you know what? They color code some of the major cost categories of this particular school, and they want to be able to add and count those different items together. Okay, well, what we have here is the background color, but this could very easily be the font color. So instead of the background being colored, you could choose to maybe make the data red, in terms of the actual font of the actual data, if you wanted to as well. That's just what they wanted it to be, the background color. And what this does is that it will count or sum based off of the background color of the school. So over here, we've got color 1, 2, and 3. And what this user-defined function does is we pass it in to parameters. Okay, first is going to be the source of where I want the data to be calculated. So in this case, it's cells D3 through G11. So look at all this particular things here, and then I tell it the criteria, in this case of what color I want it to count it on. So if it is blue, for example, we would see that blue being added to that particular total. Okay, so as an example here, if we go and we sum, or not sum, I'm sorry, but point it at other cells and we give that color, you'll see over here that that color blue is now being added to the sum and count. Likewise, let's just go ahead and add a couple more greens here. We're seeing that every time that we add it, we're seeing that value increase because why? It is being based off of the background color of that cell. Here, likewise, we'll go ahead and do this for our yellow. We could do that as well. Now, if you right click up on this example and you go ahead and select view code, you'll see that for this particular user-defined function, it is, oops, wrong one. Let's go over here to module 1 here. It's actually several different helper functions. And what this kind of really specifies is the importance that you want to divide things into their smallest unit of use and then reuse them as necessary. So this module is a collection of several different functions. So we have a function, for example, to figure out what color cell something is. So instead of having to do it in one monster function, I write one function that I can call it as many times as needed. So get the cell color. Okay, get the cell font color. So if I wanted to do this not based off of the background, but the font, I could do that. Now down here we have count cells by color. This takes a range of data. We have our color reference cell that's going to essentially tell us the cell that we want to do this conditionally counting on. We create some additional parameters here, and then we ultimately will go through a loop where it will loop through this, taking into account the first one and then adding it to the second, to the third, the fourth, the fifth, so on and so forth. We have our sum cells by color, our count cells by font color, so on and so forth. But this ended up being 1, 2, 3, 4, 5, 6 different functions in order to be able to accomplish that. So not too difficult, but by dividing it into its smallest unit, it becomes very manageable, which is something I really feel that you should strive when you're writing your user-defined functions and writing your code. So check that one out. It's definitely a really good example of some of the really cool things that you can do with respect to user-defined functions. Okay, so the last thing I want to talk about again, and I want to just illustrate this again because I think it's so useful and important, which is making our user-defined functions easier to access and use. So when we create our initial user-defined functions, they are a macro, and by default, Excel wants to store it in an XLSM file, which is dangerous and difficult to work with. That enabled macro file, for example, if you try to email it to people, a lot of institutions, for example, will straight up block macro-enabled workbooks from being sent or received from their email. That's pretty normal. So what we want to do is find a easier way of being able to manage our user-defined functions inside of Excel. And the way that I think it is to actually use what are called Excel add-ins. Okay, Excel add-ins is like an Excel workbook, but it's an Excel workbook that solely provides programs or macros or UDFs to a person. And if we do it as an add-in, it becomes super simple to maintain, super simple to be able to share and disseminate with other people. It's safer, it's more secure, and it's also going to be available in every workbook that that person does. Now, the other method would be to either create a template file, so an XLSMT file, I believe is what it's called, an Excel macro enabled template file, or we could do what's called save it in our personal workbook. But if we save it in our personal workbook, the issue with that is that if we go to save it and then ultimately share it with other people, well, unless they have that code running, it's going to error out when they try to use that user-defined function. It'll store whatever the last value is, but subsequent updates will break and it won't be able to be displayed to that user. So I think it's better to use this add-in functionality. It's very, very simple to do. And we took a look at this in the podcast one, but let's just go ahead and do it again just as a good refresher. So we create our workbook, we create our user-defined functions, we create our macros, we do it every way that I've shown you here. And it could be several macros, whatever your company might need. All we have to do then is instead of saving it as a macro-enabled workbook, choose to save it as an Excel add-in. We give it a nice name. You might call it like company names, custom functions. So imagine CPE Today, custom functions, something like that. And then we will save it as that add-in, and then we can easily share that add-in file with other folks. And once it's there, once they add that add-in, it will be super, super simple for them to be able to use and operate. Let's go ahead and take a look at what that might look like. And for this, we are going to use our first sample file that has a bunch of different macros inside of it. And I'm going to save it again just so you can kind of get a sense of where and how that would function. Okay, so we have created our tax calculation here, our married filing joint, our single, so on and so forth. And I want to send this out to my tax preparers so that when somebody calls up and they want to just shoot from the hip estimate for what they owe, I know they're giving a good, clean, consistent answer. So I've written, for example, all of my code like the way I would normally write it, so it's all listed right here. So what I would then do is that I would then, for example, come on up here to the File menu. From the File menu, choose Save As. And from here, instead of saving it as a macro-enabled workbook, which is how I'm sending you this file, if you purchase today's course and you choose to try our samples, this would be how you would open it. But instead, I'm going to come down here and I'm going to choose to save it as an XLAM or add-in file. Okay, notice once I change it to the XLAM file, notice it switches my location destination from being my user directory where I would normally save my files to my user directory, app data, roaming, Microsoft, and add-ins. Okay, and then we're going to go ahead and call this CPE Today Custom Functions. And I'm going to go ahead and select Save. And I am going to then now close this Excel workbook. Okay. Now, I want to show you where that file is located. So let's just go ahead and open up our Explorer. And we're going to come on over here and we are going to come over here to our This PC. And we're going to go ahead and select the C directory, users, CPE Today. In this case, it would be your name. And this is going to take you to your user directory. Now we're looking for a folder here called app data. Notice I do not see that listed here. It's because it's a hidden file and hidden folder. Come on over here to the View menu, and from View, we're going to go ahead and select Hidden Items, which will then expose that app data directory. From the app data directory, we're going to go ahead and select Roaming, We're going to select Microsoft. We're going to then select Excel. And then we're going to go ahead. Let's see. I think I might have screwed that up. Let's see one more time. CP today. Actually, here, let's open Excel back up real quick. And that will tell us where it should be. I always get in trouble when I try to shoot from the hip and just figure this out on my own. Okay, so we're going to come over here to our Addins Center for the second, and we're going to go ahead and choose to enable our add-in. And we will see that listed here. And let's see that directory. And I mostly just wanted to show you where it is located. See app data roaming Microsoft Addins. Okay, so I was almost right. Okay, so app data roaming, and instead of Excel, we're going to go ahead and choose Addins. Duh, it's right there. And you're going to see that custom functions add-in being listed. And that is essentially all the custom programs that might be listed for Excel or PowerPoint or whatever you choose to use. Okay. Now, the second I go into Excel, what I could do is either from the developer toolbar, choose to enable my add-ins from the developer toolbar here, or if you don't have the developer toolbar enabled, come on over here to the file menu, options, add-ins, and then go ahead and select manage Excel add-ins go, and you would choose to enable that custom functions. And when I click OK, it's going to typically give me a warning, sometimes it will anyways, and just say, hey, are you sure you want to enable this? Okay, with that Excel add-in enabled now, though, I can go ahead and put in a value. In this case, let's just say it's 100,000. Okay, and we can then use that Excel function equals MFJ 2021. And notice I can now call that function in any workbook that I choose to use. So that's the benefit and power of using the add-ins compared to using in a macro-enabled workbook. Now, when I go to save this, it's going to save just like a normal Excel workbook. And it's going to pop up and allow me to save it the way I normally would. Now, one caveat would be that if I do send this file to other people and they don't have that add-in enabled, it isn't going to work for them. It'll just show them the last displayed value. But for me, this is a much easier way to standardize, centralize where I'm saving my custom code, and it makes it available in all the other workbooks I choose to use. So I personally would recommend this add-ins approach. I find this to be a much more scalable, secure, and easier method than, for example, saving it as an Excel-enabled macro file. Okay, well, that does bring us to almost the end of our presentation here. I do want to give you a little bit more information on this. So in case you choose to go and check out other things about user-defined functions, you've got some resources that you can check out on your own. So here's a bunch of K2 resources that you can go ahead and check out, how to create custom-defined functions, samples, other code you choose to, might want to try out and give it a try. Okay, let's go ahead and have our closing review question for today. When saving a workbook containing a UDF as an Excel add-in, which type of workbook should you store that resulting file in? Is it personal.xlsb? The answer in that would be no, because that would be on your personal workbook and it would only be available to you, and that's not how you would share it to other folks. Would it be Excel start? Well, that would modify your core Excel template. Would not recommend that. The correct answer here would be add-ins. Go ahead and store those in that add-ins. Boy, is that going to be easier for you to use than any other method. So that does bring us to the end of our presentation for today. A couple of things that we learned. We learned a lot. We reviewed some of the benefits and issues with respect to creating and working with user-defined functions inside of Excel. They're great. Little couple of drawbacks that we should be aware of, but there's certainly risks and issues that we can mitigate. We took a deep dive into the terminology and functionality for macro writing inside of Excel. We learned, for example, everything about functions and subroutines and modules and parameters and everything else around that. And hopefully that gives you some good insight to some of the specifics about writing code for Excel. And we also took a deeper look at some additional user-defined examples of summing and counting by color, as well as, for example, doing the counting of words and other things like that. Now, going forward, we're going to pivot this series to look more broadly at macro development inside of Excel. User-defined functions, as I mentioned, are a great, approachable, easy way to get started, but it's a much bigger ecosystem besides just writing functions, and macros are so powerful. So we're going to pivot and take a look at that in future episodes in this series. So if you're looking to get more powerful with Excel macros, definitely stay tuned. Now, I do want to remind you, if you are a financial professional, and I hope you are, you can earn credit for listening or watching today's podcast. Whether you're watching on YouTube or you're listening on your iPhone while you're going to work, you can complete a short quiz and earn some credits for watching or listening to today's class. It's super simple. Head on over to cpetoday.com, use course code UDF2, and after you complete that short little quiz, you'll earn a certificate, which then you can have 1 credit closer to maintaining your professional licensing. Super fast, efficient, affordable. I think it's a win all the way around. Again, check out cpetoday.com, use course code UDF2. If you like today's podcast and the information presented, please consider following us on social media. We're always trying to put out new content and helping folks find the skills necessary to improve their careers and be more effective in their jobs. You can find us on almost all social media at CPE Today. You can find us on YouTube, Twitter, Facebook, Instagram, and others. If you feel that you like our content, we'd sure appreciate if you'd consider liking, subscribing, or following us. Every little bit of content and comment and review is helpful, and we look at them all. We also would love to know if you have any ideas for future podcasts or courses. You can also listen to our show at any time. We are broadcasting live most weeks, Tuesdays and Fridays at 11 o'clock Pacific, but you can listen on your own schedule. You can find us on Apple Podcasts, Spotify, Google Podcasts, SoundCloud, and others. So if you like our content and you're looking to expand your skill set, please consider liking, subscribing, maybe even leave us a review if you'd like as well. Thank you so much for your time and attention. I greatly appreciate you being here and and for your ability to follow along. Thank you so much, and I look forward to seeing you in another podcast soon. Best wishes and good luck.